Hey everyone, this is Sid Gunasekharan from the University of Dayton. In this video, I'm going to walk you through the steps for modeling the Beta Technologies aircraft Alia in OpenVSP. This is particularly prepared for the Air Masters competition as you're designing the aircraft and modifying it to improve performance or tackle one of the three challenges in the Air Masters competition. I hope this video will be useful. OpenVSP is a tool that we use in a lot of the design process of the aircraft and also the analysis. So hopefully in this video, I can share some of the basic steps that we can take to model an aircraft, especially the Alia. And you can use this baseline model to make any changes to improve performance, etc., for the competition. So let's walk through the steps to download OpenVSP. So step one, it's go to google.com and type OpenVSP download. So if you type it, click on the first link that appears. Um, sorry. The step two is you can select the right version. Now, the good thing about OpenVSP is that it runs on Windows and Mac and in Ubuntu as well. I have a Mac, so I downloaded the Python 3.11. Depending on what OS you have, and the bit, you can choose the type of file that works for you. So once you download it, it's a zipped folder. You can go ahead and unzip it. So when you unzip it, these are all the files that you will see in the folder. Uh, excuse me. So the file that we want to run is called VSP. Now there are a lot of files in here. These are all files that the main file VSP will call whenever we run like analysis. So the file that we want to open is VSP. So if you double click it, say you're downloading this for the first time, and if you double click it, chances are nothing will happen. It may throw you an error. Um, because both Windows and Mac considers this type of file as malware and prevents it from opening for the first time. So when you do this for the first time, we need to override the setting, and you only have to do this once. And if you open it again, it'll allow you to open it without any issues. So, on Mac, again, in this step, we got to give permission for the software to run. On Mac, go to settings and then privacy and security. And if you scroll down, there's a small tab here, and VSP app will appear because we double click. We wanted to open, and this security system like blocked it. So, but it'll ask you to open anyway. So go ahead and click open anyway. So if we click it, it should open. If it doesn't, just go back and double click the VSP again. It will open. On Windows, you may get something like this. So click more info, and if you click more info, the run anyway button should pop up on the screen, and then you can run anyway. So once you do that, the software will open. I'll show you how the main page of the software will look like. So I'm going to minimize this. So this is the OpenVSP software. This is how it looks like. This is the main page without nothing on it. We will create an aircraft from scratch, from here. So before creating the aircraft, we need to know the dimensions of the vehicle. So you will find the dimensions of Alia in the challenge handout, but also, I'll share this presentation as well. You can use this to look at the various details of the dimensions for wing, fuselage, horizontal, and vertical tails. So, the dimensions that I shared in this presentation just differs just slightly from the one in the handout, but it's really not that big a deal. Our goal is to model something that is close enough to the actual aircraft. No matter what, we are never going to get it exactly right, and that's not the goal. Our goal is to model a baseline design that looks like Alia, and from there, you can make changes to improve efficiency, et cetera, et cetera. All right. So the way, again, if you see some of these dimensions, you won't find these dimensions like this level of detail anywhere in an open source document. The way I found all of these dimensions is this like very advanced technique. I'm just kidding. It's just a PowerPoint tool, um, because the everything on the screen is to scale. So what that means is that if we just know one dimension of the aircraft, a common dimensions that are published open source is like the wingspan of the aircraft or the length of the aircraft, right? So if we know the wingspan is 50 feet, and we know on PowerPoint how much this a vector, this arrow, is, for example, let me go out. So if I click on this arrow, go back and see that that is about 7.5 inches on this page, but in actuality, that translates to 50 feet. So this scaling is constant for all the other dimensions. So if I want to find a new aircraft dimension, say like distance between these booms or the root chord or the tip chord, so basically I fix this ratio as constant. So that's the aircraft wingspan, that is 50 feet. The wingspan in PowerPoint is 7.5. That's from here. So because that ratio is constant, say if I want to find the root chord of the wing, say about right here, I click on this arrow that goes from the leading to the trailing edge of the wing near the fuselage, and let's say that's about 1 inch. So I put 1 inch, and if you do this math, you get around 6.7 feet. So that's a very quick way of getting dimensions of aircraft, any dimensions of the aircraft that you're interested in. And this works well for pretty much all designs as long as the scale of the geometry remains constant. Um, make sure you don't resize the figures or anything like that, so that'll screw it up. But if you keep the same figure size and use the same scaling, then everything should align well. All right. So in this PowerPoint, we have the wing dimensions, the fuselage dimensions. Um, yeah, sorry, wing dimensions, the fuselage dimensions, the horizontal tail dimensions, and the vertical tail dimensions. All right. So, all right, let's start doing this one by one. So let's go to OpenVSP. Our first job here is to design the wing. So what we're going to do is we're going to go to pod. So we go to the geometry browser, click on wing, then click add. So this will open up the the wing dimensions here. So this is just a generic wing with sweep. So now what we're going to do is we're going to make it look like the Alias Aria aircraft's wing. So um, a quick tip about OpenVSP. The way we model aircraft is by port. So we model the wing first, we model the fuselage, and then we model the horizontal and vertical tails, etc. There's a lot more you can do with the software, but we're not going to bother with all of those. Now, the main thing we need is probably you can use pod, fuselage, or wings. Okay. So I click wing, click add, and then, I have the wing geometry. Now, the first thing I'm going to do, so, if I click on the wing geometry, so I have a new tab that opens where I can control or set parameters for the wing. So if I want to unclick it, I can go, I might put my cursor anywhere in this white area and I click it and it goes away. So I want to make changes, I could come back and click wing geometry, and then this box appears. The first thing I'm going to do is rename this as main wing. So that's my main wing of the aircraft. So go right here. All right, so now let's make it look like Alia. All right, so first thing we'll do, again, we come back to rotation and all of that later on. So if we look at, I'm going to go back to PowerPoint just a bit. So if we go to the aircraft, you can see that it's made out of like, it's not a simple, straightforward rectangular wing. So there is a first section. So I'm going to just draw a quick box. So we're going to model this section. First, call it section one, and then we're gonna model the rest of the section as section two. This is a section two, all right? Now in aircraft, so in OpenVSP, we don't model the entire wing. We just model half the wing, and then the software mirrors it. All right. So we model half the wing, and then the software will mirror the other half. All right. So I'm going to do this in two sections. So section one and section two. All right. So let's do that. Let's go back to OpenVSP. All right. So, so now we are going to go to this section. So again, you can see here that there is only one section in here, right? Which is fine. That is fine. Let's before we do that, let's click like an insert. So now we added a second section, right? So now the wing has two sections. Now you can see here, like the wing has two sections. Um, right here. So now what we're going to do is we're going to assign the dimensions for each of these sections. All right. So let's go to the first section. What is the root chord of the first section? Well, the root chord of the first section is 6.7 feet. So I'm going to go to the root chord and type 6.7 feet. Okay. And then the tip chord is 5.4. So tip chord is 5.4. And then the span of this first section is 16.7. But keep in mind that we are only modeling half the span. So 16.7 divided by 2 is what, 8.35? So I'm going to come here to 8.35. All right. So how that looks like, so there's our first section. However, you can see that the section has a sweep, but the actual aircraft's wing doesn't have a sweep, right? Doesn't have a sweep. So what we do is if we go to the sweep section on the OpenVSP, we can the default is 30 degrees, but we can change that to 0. There you go, right? Now our sweep is removed. So our first section kind of looks like the section on Alia, right? Which is great. So that's good. Now let's model the second section. So let's go to the second section. Okay. So the way you know what section you're in is by this green box. So if I toggle between section one and two, you see that the green box keeps switching, right, from section one and two. That's how you know what section you're in. Okay, so second section, I'm going to keep the root chord of the second section to be 5.4 as well. I'm going to do 5.4. All right. So, and then the tip chord to be 2 feet. So tip chord is 2 feet. Right. All right, so now I need to know what the span is. So the span of the wing, of the full span, is 50 feet, so half is 25, right? So I need to subtract 25 minus uh, half of 16.7. So if I go to Excel, so I can do 25 minus 16.7 divided by 2, which is again 55, right? So I get 16.65. All right. So I can go to my span here and type 16.65. All right. So here we have our wing. But wait a minute, right? This doesn't quite look like Alia because there is a little bit of sweep. Now, the sweep, you can think of it as whether the leading edge remains straight or the trailing edge remains straight. So in Alia, right, if you look at the wing designs for section two, the trailing edge remains flat and the leading edge is swept back, right? So we can create a similar variation by just adjusting the sweep a bit until we are satisfied um, with the orientation of the trailing edge. So, okay, that's not bad, right? So there it is. All right, there it is. Okay, so we put about 12-degree sweep for section two, and we get something that looks like the alias wing. Now, I'm not going to model the wingtip. If you choose to model the wingtip, the winglet, you can do so. But again, our goal is to get somewhere close to the baseline and make modifications later on. But it's really up to you. on how detailed you want the design to be. But again, in the analysis frame, small details may not create that big of a change due to the limitations of the analysis tool here. But you're more than welcome to model it anyway and see if it makes a difference. All right. So the what so that's our wing. Um, so the one thing that I'm going to do is assign some material to it, just so that it adds some color later on. So let's do blue. Okay. So what that does is that, like, so I click blue color, but you don't see blue because we want to display the wire mesh. So I'll go click on main wing and then click shade. Not quite blue. So let's maybe do rubber or black. There you go. It's black, but it's too dark. Ah, I'm wrong. All right. Well, we can play with the colors later on. That is just to make it look nicer. But all right. So we got the wing right here, right? Which is cool. That's pretty cool. Um, all right. So let's let's now model the fuselage. All right. Let's go to fuselage and then click add. All right. So here's the fuselage design, right? But once again, we need to make sure that the fuselage resembles the fuselage of the Alias aircraft, right? Now, the first thing that we will do is orient the fuselage with respect to the wing correctly. So that means, right, if I look in the design, the fuselage length is about 29.2 feet. All right. So I'm going to click on fuselage, um, go to design. Then I'm going to set this to 29.2. Okay. So I got my design. But then the nose of the fuselage is about 9.4 feet from the main wing. So what I'm going to do is move the X location by negative 9.4, right? So that will put the fuselage in the right orientation as the main aircraft, right? So this is good. Now, similar to the wing, the fuselage is also designed in different sections. All right. So if I go back here, and let me remove this for a second. All right. If I go to section, right? So, like, if you notice, right, I have four sections. That's a default. So whenever you initiate the fuselage, you will have four sections, and each section is defined by, is highlighted by this black line. So when I click to two, I can see that, like, the line appears, that's three, and then four. So you have the initial point, one, two, three, and four. All right. So that's good. Oh, sorry. So zero, one, two, three, four. Zero is the leading point right here. That is one, that is two, that's three, and the last point is the tail end of the fuselage. All right. So now we have to set the width of each section so that once again it resembles the alias wing. All right. Now, in most cases, an aircraft fuselage won't be a perfect circle. So what we need to do, and as you can see here, like, the diameter of the fuselage, when we look at it from the top, it's about 4.7 feet, right? So I'm going to put the width of the first section as 4.7. All right. But the length, as you can see there, it's 6.26 feet. So I'm going to come to the height as 6.26. Okay. All right. Look at there, right? 6.26. Now I'm going to match the same parameters for the section two of the fuselage as well. 6. Okay. Right. That's section two of the fuselage right here. All right. So, but also, as you notice, right, the wing is in the middle of the fuselage, which we'll move the wing later. but I want to first model the fuselage, right? And then we'll move the wing to sit on top of the fuselage and not in the center. All right. Okay. So the tip of the fuselage is actually a little bit down, right? It's not in the center. So let's go to 0 and notice the orientation. X is along the length of the fuselage, Y is along the span, and Z is the height. So that means I go to 0, which is my leading edge of the fuselage, and I can move my point down so it looks like, the aircraft. All right. So that is my fuselage. Um, but you can see that, on the actual aircraft, the tail end is actually a little bit up when compared to the leading edge. So I'm going to go to section 4 and then move the tail a bit up. And I'm going to do the same for number 3 as well. Okay. All right. Again, you can try to be exact, but remember our goal is to get something close enough. All right. That is what's important. All right. So we got we got something similar to what how it looks like on Alia, right? All right. So now we did that. Let's go back to general. I'm gonna rename this to fuselage, and maybe give this material black. Once again, this is just for coloring. Nothing else. Shade. There you go. The one thing that we still need to fix, again, look at there, right? On an actual aircraft, the wing sits on top of the fuselage, not at the center. So let's go back to the main wing, right? Go to X form, and we need to increase the Z location so that the wing sits on top of the fuselage. All right. Again, you can eyeball it. Doesn't have to be exact because once again, the goal is to get something similar, not exactly right. Okay. So now we got our fuselage and our main wing. Um, let's model the tail as well. All right. So if you go to the geometry browser, um, you'll see that like, well, there's no horizontal or vertical tail here because, well, if you think about it, horizontal and vertical tail are nothing but wings, just placed in a different location, right? So pretty much what we do is we'll just add click wing and do. Oop, hold on. I need to make sure. I'm gonna cut this. All right. So we, the chain of parts that you do here, right? You can stack subcomponents inside each component, but I want the horizontal tail to be its own part. So if I click this and then click add, the tail is going to be added as a subcomponent of the main wing, which I don't want. I want this to be a separate part by itself. So I'm going to make sure to click on this white space, make sure nothing is selected, and then go to wing and then click add. So now you can see that that new component is its own component, right? So I'm going to rename this as horizontal tail. Okay, that's my horizontal tail right there. So as you can see, like, well, horizontal tail well needs to be towards the tail end of the aircraft. So what I'm going to do is going to do the X location, move. I'm going to look at the side view, sorry, the side view, and move the tail until I'm satisfied. So I got the X location. Now I need to adjust the Z. So it's about right here. Okay. I'm just looking at, the actual aircraft and finding the right location. Okay, so now let's make sure the root chord, so tip chord and the span, those are all correct. So let's go to section. Uh, right, root chord for the horizontal tail. Let's go to the horizontal tail. Root chord for the horizontal tail is 2.56. 2.56. The tip chord is around 3.68. All right. And the net span is 21.46. But once again, we are only modeling half of it, correct? So, so half of 21.46, right? It's close to what, 10.05? That's close enough, right? So here's our horizontal tail. All right. Now, it does have some sweep. It kind of looks like a 30-degree sweep, so I'm going to leave it as default as it is. However, if you actually look at Alia, the front view of Alia, there's a little bit of dihedral to the tail. Dihedral is, how the wing is like pushed upward a bit. So if I go to dihedral here and put like 12 degrees, I look there, right? That's kind of how it looks like on an actual aircraft. So if I go back and look at the side view, like there is a dihedral, but the horizontal tail is pushed up a bit. So, and that's what we are modeling here. All right. Okay. So we got our horizontal tail. Once again, I'm going to just give it some color. Let's do ruby. All right. All right. So we got, that's a terrible color choice, but anyway, I'm not good at coloring things. Um, maybe let's make it. Uh, Trust me, I spend way too much time on coloring than I should. But anyway, looks good. All right, that's starting to look like Alia. Uh, just one last thing that we can add is our vertical tail, right? So let's add the vertical tail as well. Uh, let's go back, click here, click wing again. Wing vertical tail is still a wing, right? We'll click add. Once again, I need to orient it in the right spot. So I'm gonna go here and go to X form, make sure the wing, the vertical tail lines up with the horizontal tail. Um, Again, I'm just eyeballing it because once again, I keep telling, we just need to get close enough, right? So, okay. So, that looks good. That looks good. We still need to increase the Z location. All right. So one thing you notice, right? Vertical tail, well, needs to be rotated. Right now, the wing, the vertical tail we have here, let me go back and rename that, right? That's vertical tail, right? The vertical tail, well, it's not a vertical tail, it's still a horizontal tail. So we still need to rotate it. So let's, along which axis we are rotating? Well, we want to rotate about the x-axis, right? We want to rotate this about 90 degrees. But we also want to separate the two wings because they both will act as vertical tail. So for that, we change this y location. You see the y location, right? So we change it until we get to the right orientation of the wing. So I'm going to change this until I match up with the edge of the horizontal tail. Excellent, right? That looks pretty close. So now what I'm going to do is go back to the actual vertical tail dimensions and try to match that. Let's go to section. So the root chord is 3.68. Tip chord is 2 feet. And then the span is about 6 feet. Okay. All right. Now that looks reasonable. So I'll still try to match and align it, just a little bit more so that it looks nicer. Um, yeah, I think that's pretty cool. That's good. All right. So let's go back, give it some color, shade. All right. So look what we got here, right? We get something that looks like the Alia aircraft, which is pretty good. Now, for all analysis purposes, this is more than enough, right? This is our basic wing fuselage tail designs. And if you start making changes to this design to say different performance, uh, that alone will give you enough details to see performance changes. Now, if you're interested in adding like these twin booms, we can do that as well. But once again, like we need to get the dimensions correctly, uh, and we need to set, the distance between the fuselage and the wing, and all of those things, right? Um, just so that you see it, we can do one, but once again, I just want to tell you that it's definitely not necessary. We don't, right? We really don't need to worry about these because these won't add anything to um, the overall design itself. Okay, I'm just tweaking it so that, sorry, so that it looks kind of close to what it looks like on Alia. All right. So this is kind of how we do it, right? Um, so depending on how detailed you want the design to be, you can again calculate the exact dimensions and all of that. But once again, for these purposes, um, I'm not going to worry too much. So there's my pod. Um, Once again, I just modeled it without actually doing any calculations, like the diameter and all of that. But, you know, but just once again, keep in mind that, you really don't need this. Um, so this is five left. Oh, sorry, five right. Then we can add, so I'll do copy, paste, do five left. And then I'll change the Y location uh, from positive to negative. And sure, there you go. All right, we got something that looks like Alia, within, 30 minutes or so. You can, the propellers, you really don't need to model them. In fact, they only heard the analysis. So, because the analysis tool built into OpenVSP can handle propellers, but it requires a bit of a learning curve to know how to properly set them up. For this analysis, it's really not that you don't have to worry about it. So anyway, this is how you model an aircraft in OpenVSP to make it look like Alia. Hopefully, this is useful. I'll create another video showing you how you can run some basic aerodynamic analysis in the same software. It's also like pretty simple to do, and you can get like lift, drag, etc. Oh, before I forget, I do want to tell you one thing that is very, very important, right? If you're going to improve performance, right? The main way you can do that is through careful selection of airfoils for wing and the tails, right? What do we mean by airfoil? So if I zoom closer, right, look at the cross section. So that is an airfoil. Now, how do we know what airfoil to choose, right? Now, that's a very important question. The performance of the aircraft strongly depends on the airfoil you choose. So what airfoil we chose now? So if we go to main wing and go to airfoil, The default airfoil is NACA 0010, which is a symmetric airfoil. Again, not you may need to learn a little bit about basic airfoil aerodynamics, but when you play around with the different uh, series airfoils, you will get drastically different performance metrics because the aerodynamics of an aircraft is very, very, very sensitive to airfoils. All right. So even a 2% change in thickness of the airfoil can have drastic effects in the overall performance of the aircraft. All right. So just I'll add another resource on how you can test different airfoils using another uh, software called XFLR5. But just know that you can choose different airfoils for the wing, the root of the wing, tip of the wing. You can have multiple different airfoils on the same wing itself, right? That all leads to different performances. Um, so, and that's how you do it. So in the next video, I'll talk about how you can do a quick aerodynamic analysis on this aircraft. All right. All right. I'll see you in the next video.